Hi, in this video we're going to create an ordered list class which is going to be based off of the linked list. This one is going to be similar to the unordered list. The difference is that when we do something like an add or remove a little bit on the search, it's going to be different on how we do those because of keeping the linked list data in order. So I'm going to start a new file here. And we're going to get going here with creating this. In this, we're going to need our node. So from node, we're going to import node. We're going to call this ordered list. Create our constructor. And in here, all we're going to do is self.head equals none, just like in the unordered list. Our next one's going to be our is empty. Same thing on this one. We're going to return self.head equal none. Oh, no colon after that. So let's back that out. There we go. Okay. Next one's going to be our add. We have to pass in an item that we're going to add to this. Now this one's going to be a little bit different because we've got to find the right location for this. So we're going to start off with current equal to self.head. We've got to find the location where it's going to go. Previous is going to be equal to none because when we find the location, we have to have the one before it in order to fit it in there. We're going to set stop equal to false. This is going to tell us when we find the location. So now we're going to do a while loop. For current not equal to none and not stop. Okay, so now in here, what we're going to do is we want to check to see if the value that's in data where current is sitting, if that's greater than our item, we know that we found the right place and our new node is going to go in front of that one. So if current.getData is greater than item, then we're going to set stop equal to true. Else, we need to move to the next one. So previous is going to be equal to current, and current is going to be equal to current.get next. Once we have get done with that, hopefully it will be at one of two places. Will either be someplace in the middle at the very beginning one, or before the end, or we'll be at the end, meaning that the number we're putting in there is larger than anything we have in there. So now we're ready to figure out where we're going to put this. So temp is going to be equal to node passing in item. Okay, now we need to check to see where we're located in the list to see where we're going to put it. So we're going to check to see if previous equals none. That means it's the first item in the list is greater than the one we're putting in there. So then temp.set next to self.head, and then self.head is going to be equal to temp. Okay, so that gets a position in the first place. Else is someplace else in the list. So temp dot set next to current and previous dot set next to temp. Okay. So then this gets it positioned in there right behind the one that we found with the data being greater than our item. Squeeze this down here a little bit, and so we have a little bit more room in here. Okay, so the next one we're going to do is the delete. I'm sorry, the size, the EF size. Put some blank lines in here so I get some room. So now, current, this is going to be similar to the other one we did. Actually, probably the same thing. Current's going to be equal to self.head. Count is going to be equal to 0. And then we're going to run it through a for loop on this. Or while loop, sorry. While current does not equal none. So while we're not at the end of our list, count plus equals 1. And current equals current dot get next. Okay, and then we're going to return count. Okay, next one we're going to do is search. And two things with search, since it's ordered, we know that if we get to the place where the item we're looking for is less than, let's see, let me back up here. If the item we're looking for is greater than the last item, or less, let's see, I'll think of it here in a second. We're looking through, we're making the comparisons, and once we get to a place where the item we're looking for is greater than the item, our item, then that means we haven't found it. It's not in there, so we can stop. So we can stop a little bit faster than an unordered search where we have to go through the whole thing. If the item isn't in there, we have to go through the whole thing to determine that. So we're going to set current equal to self.head. We're going to set found equal to false. And we're going to set stop equal to false also. And we'll do our while loop. So while current does not equal none and not found and not stop. 3 different ways that we can get out of the while loop here. If current dot get data equals item, we found it. So we set found equal to true. Else, if current dot get data is greater than item, then we set stop equal to true, because we know that it's not going to be in there. And then else, current equals current dot get next. So then all we need to do is return found. So all we're doing is searching through to see if the item is in there or not, and then returning whether or not it is. Okay. Our next one, remove. Again, we can use the, well, actually, in this one, it's going to be really close, or if not exactly the same as the unordered, because we're assuming that the item is in the list. So there's no reason to stop early like we did with the search on here. So on this one then, current is going to be equal to self.head. Previous is going to be equal to none. Found is going to be equal to false. And one thing about this too is that since we have to assume that the item is in the list when we do a remove, we can or we should do a search first to make sure that it is in the list before we do the remove. Okay? So just something to think about when you're using this in an application. So while not found, if current dot get data equals item, then found equals true, else previous equals current, and current equals current dot get next. So once we have that, we just have to determine where it was located. So previous equals none, then self.head is going to be equal to current dot get next, means it was the first item that we're removing out of there, else previous dot set next current dot get next. So that's going to wrap the or change the pointer from the one that previous is pointing to around the one that current is pointing to the next one. We want to do a print to print out all the values in here. So this is going to be similar to or the same thing as the one for the unordered list. So current is going to be equal to self.head. While current does not equal none, we're going to print current dot get data, and then we're going to end with the equals quote space quote, so we have a space between it. Whoops, back over. So then current equals current dot get next. And then once we get done with that, we want to print a blank line. Okay. So that's the whole ordered list class. So I'm going to go ahead and get this saved. And I'm going to save it in here, and this is going to be ordered list.py. Get that saved. Okay, so I'm going to leave this up for now. And what I'm going to do is we're going to do a example program to test this out. I'm going to create a new file or open a new file. So we're going to do from ordered list, the file that name of that saved it under. We're going to import ordered list. And then in our main, we're going to do a my list be equal to ordered list. Then we're going to do a bunch of adds here. My list.add 31. mylist.add 77, mylist.add 17, mylist.add 93, mylist.add 26. Okay, I'm going to do a print. Actually, my list.print list, I'm going to put a message up here before that in my current list. I'm going to do this first, and then we'll come back and add more to it. Okay, so let me get this saved. Save this as ordered list test.py. And let's see if this runs or if I got some errors in here. Yep, there's my first error. The EF remove, that's why I kept this open. And I do this every once in a while. I put dots in there instead of commas. Resave this. And move this over so I can see these better here. And then we'll run this again. There we go. And there's our list in order, 17, 26, 31, 77, 93. Okay, so that all worked. So let's add some more code to this. Put a little blank in there. So I'm going to do some testing of the other ones. Is my list empty? Is 31 in list? Is 45 in list? And then we're going to do remove 17 from the list, and then we'll print list after remove. Do remove instead of removal. There we go. And then there we go. Okay, so let's run this and see. Make sure we don't have any errors in any of the other modules. There we go. Current list. Is list empty? False. Is 31 in the list? Yes. Is 45 in the list? False. Size of the list is 5. 1, 2, 3, 4, 5. List after removal. And we removed 17, and 17 is not in the list. There. So everything worked on there. So let me know if you have any questions, or let your instructor know if you have any questions. And we'll continue on with some other videos after this. Bye.